and integration with LLMs is not built into most vector databases. That's where RAG frameworks fill the gaps by connecting all the pieces. Tools such as LangChain and Llama Index wrap around your vector database and help manage the pipeline from document prep to final response. Thesis. Then, this user's prompt is... Welcome to this video, How Vector Databases Power RAG. After watching this video, you'll be able to describe what RAG is and the problem it solves, describe each of the key steps in a RAG pipeline, explain why you should use vector databases to perform many of the steps in a RAG pipeline, and describe the pitfalls to avoid in a RAG pipeline. In this video, we'll explore how vector databases are not just a part of retrieval augmented generation or RAG, they're the backbone of it. So let's walk through how vector databases power the RAG pipeline. But first, let's recap what RAG is. RAG is a framework that enhances language models by retrieving relevant information from external sources and using it to generate more accurate grounded responses, and thereby reducing the amount of potential hallucinations that may occur. LLMs, while capable of processing large amounts of data, have limited context windows, so it's not possible to include all information in a single prompt. Moreover, their knowledge is frozen at the point at which they are trained, and they can hallucinate facts. RAG addresses these issues by retrieving and injecting relevant knowledge into the prompt. Let's have a look at an example of all the steps in a full RAG pipeline. First, source documents that are relevant to the use case are provided and potentially split into smaller chunks. Next, the source documents or their chunks are embedded. Then, these sources and their embeddings are stored in a vector database such as ChromaDB. Next, a user's prompt is received. Then, this user's prompt is embedded. A retriever then selects the chunks from the vector store that best match the user's prompt. Next, the retrieved text is combined with the user's original prompt to produce an augmented prompt. And lastly, this augmented prompt is passed to the LLM to produce a context-aware response. Vector databases play a central role in the RAG pipeline. They can handle several key responsibilities such as embedding both source documents and user prompts, storing those embeddings, retrieving the most relevant matches, and supplying the retrieved content for prompt augmentation. This represents the full extent of what most modern vector databases are capable of. However, some of these steps, such as embedding the documents and prompts, steps 2 and 5, can also be performed externally. In such cases, the vector database is used primarily for storing and retrieving vectors. Let's now discuss why you would want to use a vector database to perform most steps inside a RAG pipeline. First off, using it for storing and retrieving vectors. Let's now discuss why you would want to use a vector database to perform most steps inside a RAG pipeline. First off, using a vector database helps prevent critical mistakes, such as accidentally using different embedding models for source documents and user prompts, or incorrectly linking embeddings to their corresponding source database helps prevent critical mistakes, such as accidentally using different embedding models for source documents and user prompts, or incorrectly linking embeddings to their corresponding source documents. Secondly, development becomes faster and cleaner when more steps are offloaded to vector databases. With fewer moving parts and less custom logic, your code base stays simpler and easier to maintain, which in turn makes it faster to implement and debug. And lastly, performance is a major advantage. Vector databases are built for high-speed, scalable semantic searches using advanced indexing algorithms. Custom-built alternatives typically cannot match this performance without significant optimization effort. Vector databases are powerful, but even with the right tools, there are common mistakes to watch out for in a RAG pipeline. Some of these pitfalls can be avoided by using a vector database. Others require more careful attention. For example, using different embedding models for your documents and queries can break retrieval entirely. So use the same embedding model throughout. Vector databases usually handle this automatically. Another pitfall is choosing a poor chunking strategy, creating chunks that are either too large or too small, which can also negatively affect performance. Therefore, Choose a chunk size that is long enough to preserve meaning without including too much irrelevant content. Another common pitfall is forgetting to re-embed your content. After changing the data, distance metric, or embedding model. For some databases, such as ChromaDB, this cannot be done on an existing database and might necessitate cloning your collection. And finally, just because something is retrieved doesn't mean it's the best answer. Therefore, you should always test your results, because a little tuning can make a big difference. Vector databases are essential to RAG, but they don't do everything. Some RAG pipeline tasks usually happen outside the database. For example, chunking is usually done before data enters the vector database. Advanced retrieval logic, such as filtering and re-ranking, may require extra tools. Prompt augmentation is also typically handled outside the database. And integration with LLMs is not built into most vector databases. That's where RAG frameworks fill the gaps by connecting all the pieces. Tools such as LangChain and Llama Index wrap around your vector database and help manage the pipeline from document prep to final response. These frameworks provide additional structure and simplify the development and deployment of your RAG application even further. In this video, you learned that RAG enhances LLM response quality by retrieving relevant external information, helping the model generate more accurate and well-supported outputs. Vector databases are the foundation that makes retrieval-augmented generation work. The tasks vector databases can perform in a RAG pipeline include embedding source documents and user prompts, storing embeddings, retrieving most relevant matches, and providing the retrieved